This is Chapter 10, Section 4, which is going to be finding probabilities of disjoint and overlapping events. So in the last section, we did probability, introduction to probability, basic stuff. So we're going to get into a little bit more detail here. It'll be a little bit more complex. There are going to be parts of this that may get confusing. Just try and focus in on some of the things that are confusing, rewatch where needed, and really I'll try and go slow through some of it. So the three terms for vocabulary that we need to know is a compound event is the union or intersection of two events. Two events are overlapping if they have one or more outcomes in common. Okay, and then two events are disjoint if they have no outcomes in common. So the reason why this section is a little bit different is because we're going to start dealing with two different things happening at once. So instead of us just saying, oh, we're going to pull red 5 out of the deck, that's just a single event. What we're going to be doing now is we're going to be considering more than one event and figuring out whether they are joined or whether they're disjoint. It's typically easier to do a disjoint, but every once in a while we'll have overlapping, and we need to deal with that as it comes. So when you consider all the outcomes for either of two events, A or B, you form the union of A and B. When you consider only the outcomes shared by both A and B, you form the intersection of A and B. The intersection or union of two events is called a compound event. To find the probability of A or B, you must consider what outcomes, if any, are in the intersection of A and B. Okay, so let's just go through this. I don't know why I started reading through that. You probably could have read that on your own. So if you see these diagrams, I know that you're used to Venn diagrams. This is the union. That means that both occur. That means one or the other. This is the intersection. So the middle is just the and. Okay, that means that this and this occur. So therefore only the middle is considered. And then intersection is empty because there's nothing there. That would be a disjoint. So let's look at the probability of compound events. It's actually pretty easy. So if we want the probability of A or B, then all we are doing is adding the probability of A plus the probability of B. Okay, so probability of A plus the probability of B. And then what we need to do is, because we want one or the other, we need to subtract off whatever intersects between them. Okay, so the idea there is that if there's an intersection, we can't count them twice. And if we're dealing with the probability of A and then the probability of B, there are things that intersect between them, and we don't want to repeat those, so we have to subtract that off. Okay, so and you'll see that in the examples that we do. And then down for the disjoint, which is really the easiest. If there are no overlapping events, then it's just simply going to be the probability of A plus the probability of B. So let's look at this example here so you can kind of understand where we're coming from. It says a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? Okay, so we're trying to find the probability of an or event, one or the other. Well, if you look at this, one event is a 10. So we have 4 10s out of 52. That's this part. Now, the one thing you got to realize is that 10 and face card do not overlap at all. This is a disjoint event. Okay, so so it's actually a little bit easier. They will never overlap. So we have 4 out of 52 10s, and we have 12 out of 52 face cards. So you just simply add those two probabilities, and you get 16 out of 52, which is 4 out of 13, or 0.308. So that should be pretty easy. Again, you're just finding the probability of each individual event, and then you're adding because they were disjoint. So go ahead and do this one on your own, and then hit play when you're ready. All right, so hopefully this one was pretty easy. 6-sided die is rolled. What's the probability that a number rolled is less than 3? So 2 out of 6. Less than 3 means 1 or 2. And then or greater than 5. Again, it's disjoint. You will never have, they don't overlap at all because it's less than 3 or greater than 5. So that means we can have a 1 or a 2, that's 2 out of 6. We can get a 6, that's 1 out of 6. You add those together, it's 3 out of 6, which is a total of 1/2. One or the other. Okay, so let's move on to the next page. Okay, so what I want you to do is I want you to try this on your own. It's, you know, a Venn diagram, maybe it's been a while maybe since you've done this, but I want you to draw your Venn diagram, and I want you to see if you can actually come up with each of these. So come up with each of these individually, okay, but let the Venn diagram help you do what you need to do. Okay, so in one of them, it'll be the probability of A, which is the face card, and the other one will be the probability of B, which is a spade. What I want you to do, though, is when you draw your circles and the overlap would be the ones that are face cards and a spade. Okay, so try and do that and hit play when you're ready. So when I did this problem, what I did was I put all of my face cards over here on the left, except for the spades. The spades ended up going in the middle. So king of hearts, queen of hearts, jack of hearts, king of diamonds, queen of diamonds, jack of diamonds, king of clubs, queen of clubs, jack of clubs. And then I did my king of spades, queen of spades, jack of spades. And then over on the right, those were all my other spades. 2 of spades, 3 of spades, 4 of spades, all the way to the 10 and then the ace of spades. So now it's easier for me to do this if needed. So we're drawing this randomly out of a deck. So the probability of A, which was to get a face card, there's 12 face cards out of 52. The probability of B, which was getting a spade, was 13 out of 52. And as you can see, what we have here is we only have 3 face cards and spades, so that is 3 out of 52. Okay, so all we simply do is do 12 out of 52 plus 13 out of 52 minus the intersection of the and. So we end up with 22 out of 52 equals 11 out of 26. So again, all you're doing is step by step your probability of A, probability of B, the probability of both, so you want to see where they overlap, and then you just use your formula. Okay, so there's another one for you to do on your own. You don't have to do a Venn diagram unless you feel the need to, but you should, you know, maybe write out all of these so that way it's easier. So hit play when you're ready. All right, so for this one, we wanted the probability of rolling a number greater than 4 or even. So the probability of rolling a number greater than 4, 5 or 6, is 2 out of 6. The probability of getting an even number, 2, 4, or 6, is 3 out of 6. Now the overlap is, what is an even number that is also greater than 4? It's only 6. So the probability of that would just be 1 out of 6. So then we do probability of A or B is 2 6 plus 3 6 minus 1 sixth is 4 sixths, which reduces to 2/3. Okay, so let's move on. So here's where it gets a little bit trickier. So we have, we're dealing with a senior class that says out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. So it's an or. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So in this one, we're given the or, but we're not given the and. So we want to fill this in as necessary. So probability of A is just 74 out of 200. That's varsity athletes. Probability of B, which is honor roll, is just 51 out of 200. That should be easy. Total students and the number of students that are there. But now the probability of A or B is what we're given. That's 113 over 200. So now it wants us to find what's the probability of both. Well, we use the formula that we used before. The same one that we've been using pretty much this entire section. And now we just plug in what we have. So plugging in what we have, instead of us plugging in the A and B, which is what we don't have, we plug it in over here because we have the or. So the 113 over 200 goes here. The 74 over 200, same spot. 51 over 200, same spot. And then we just solve this equation. Solve for this missing one. So basically what the next step does is it adds the P, it adds this part, this unknown to the left side, and it subtracts this to the other side. So it's literally the same exact equation. It's going to be probability of A plus probability of B minus the probability of A or B, and that will give us what the probability of A and B is, which ends up being just 0.06, which is 6%. Okay, so I want you to do this one on your own after looking at this one. So do this on your own, follow along with this example. It's pretty much the same idea. Okay, hit play when you're ready. All right, so On this one, again, if you're struggling with this a little bit, I'll walk through this one for you. We have 100 students surveyed, 92 either own a car or a computer, so that's your or, so that's where the 92 over 100 comes from. 65 own cars, so that's A, 65 over 100. 82 own computers, that's the 82 over 100. And then we just set up our equation. 92 over 100 equals 65 over 100 plus 82 over 100 minus the P of A and B. And then we just solve for that. So you should have gotten 55%. Okay, moving on. Okay, so the last part that we're going to talk about is called the complement, which means the probability of something not happening. So it's all of the outcomes that are not in what we want. So what is the probability of this not happening? What's the probability? So essentially, what we need to understand is that the probability of something not happening is going to be 1, which is the same thing as 100%, minus the probability of it actually happening. So we can always figure out the probability by doing 1 minus of it happening will always be the probability of it not happening. So real quick, here's what I want you to do. I want you to go through and tell me what the probability of, or the complement, what's the complement of the probability of A. So if this one is 0.45, then this up here would be 0.55 because it has to add up to 1. So go ahead and do the other 3 on your own. Hit play when you're ready. Okay, so hopefully you got 3/4, 0, and then 0.97. Again, they have to add up to be 1. So it's 1 minus 1/4 is 3/4, 1 minus 1 is 0, 1 minus 0.03 is 0.97. Okay, so let's look at this example over here on the, actually we're going to look at this last. So let's look at this example right below. So events A and B are disjoint. Find the probability of A or B. Well, this one should actually be really easy because we already talked about this briefly. If it's A or B, if I have A and I have B, it's one or the other, and they're disjoint, that means there's no intersection, then you're just adding these two. So it's 0.55 plus 0.2 equals 0.75. So that would be the probability of A or B. All you're doing is adding one or the other, add them together, there's your probability. Okay, do this one on your own, hit play when you're ready. So again, hopefully on this one you got 1, you just added the two fractions up and got 5 over 5, which is 1. Okay, so what I want you to do is try and do this one on your own. This is very similar to the last problems on the previous page, just everything is given to you already. So figure out what P of the probability of A and B is given all this information. So use that formula on the previous page and hit play when you're ready. And in fact, why don't you go ahead and do 6 as well, because that's just using what we did up here with the complement. So go ahead and do all of these going down, and then we're going to look at these two problems. Hit play when you're ready. Okay, so hopefully on this one you got 0.1 as an answer when you plugged into the formula. Down here, the card is not a 7. Well, one way you could do it is just say there's 48 cards that are not a 7 out of 52. Same thing, not a red face card. There's 46 cards that are not a red face card out of 52. Or you could have figured out how many 7s do you have and subtracted that from 1. You get the same answer either way. Okay, so we're probably not going to have enough time to do it in this video. So go ahead and this video is going to be done, and start the part 2 of this video. It should only be about maybe 3 or 4 minutes.